So, you've probably heard of audio effects before, right? You know things like EQ, reverb, and delay? Well, if you haven't, then you're at the right place. In this video, we're going to understand how an audio effect works, and we will also have a look at the most commonly used audio effects in the music industry. Let's start off with the explanation of the audio effect. When we imagine how an audio effect works, we could simplify it as something going in and something stylized coming out. Just like us after we come out of the hair salon. But instead of a person, an audio signal is used. If we look closer into how an audio signal looks like, we can see that it is a series of waves that vary in rate and intensity. The rate of the wave, or specifically how fast it alternates, defines the tone, and the intensity of the wave defines the volume of the tone. When we talk about tones, we will usually talk about frequencies, or hertz. For example, if we say the tone is 100 Hz, then that means that the wave alternates 100 times in a second, and for 10,000 Hz, the wave alternates 10,000 times in a second. Then a volume is given to that tone, that is regulated by the intensity of the wave. In music terms, we describe volume, or sometimes called amplitude, in decibels, or dB for short. But when we increase in decibels, it doesn't just increase normally as we think it does. Instead, every decibel is 10 times louder than the last one. So, if we imagine one speaker playing at 80 decibels, to increase to 81 decibels, we would need 9 more speakers to reach that volume. Enough talking about audio signals, and instead get to the good stuff. We know an audio signal gets fed into an audio effect and somehow comes out differently than it was before. When we talk about where audio is fed in and where it comes out, we talk about an input and an output. For the input, we give the audio that we want to get processed, and we then get the processed audio from the output. Sometimes an audio effect has several smaller audio effects combined, so a volume knob is given per output channel, or even just one if the output volume needs to be changed after the audio signal got processed. A lot of audio effects process the audio signal and output that, but also output the original one as well. So another knob is used to control how much of which signal gets output. So in this case, the processed one is called a wet audio signal and the original one is called a dry audio signal. With that, we can set the amount of how much of the dry or the wet audio signal gets output using the knob. The most important thing about audio effects is the arrangement. What this means, if you have one audio effect in front of another, it won't sound the same if it's the other way around. So before you start applying audio effects, first think about what final sound you want to achieve. Now that you know the basics of applying audio effects, let's get to our first audio effect, the EQ. The EQ is one of the most used audio effects in the music industry and can either exist physically or electronically. In production, an EQ is used to filter out or boost certain frequencies. This can be achieved by either decreasing or boosting the volume of a specific frequency range. Normally, EQs are used to control 3 frequency areas: the bass or lows, the mid-range or mids, and the treble or highs. There are several types of equalizers that exist. The first one is a graphic equalizer. A graphic equalizer has many sliders that are able to control many frequency ranges at once. This allows the user to have a lot of control of which areas to decrease or boost. Then there are the parametric equalizers. These types of equalizers have several knobs that can control how the EQ behaves. The parametric equalizer has several parameters: center frequency, bandwidth, and amplitude. With the center frequency, the center of the EQ spectrum in Hertz is given. From this point on is where the other parameters are being controlled. The bandwidth defines how much of the surrounding frequencies should be included with the center frequency, and the amplitude defines the boost or decrease of the frequencies that were chosen. These kinds of EQs are commonly used in music production. The main benefit of using a parametric EQ is that you can predefine which frequencies you want to influence. Additionally, there are semi-parametric EQs that also allow to change the bandwidth and amplitude, but only on predefined frequency ranges. Finally, there are the visual parametric equalizers that are used in most music production softwares. The main benefit of it is that you can see the exact EQ curve, which is much more helpful than just rotating knobs. Now that we have seen all of the types of EQs, let's get to Ableton to showcase how we would work with an EQ in music production. So, welcome to Ableton. As you can see already, I have a project set up with a plugin and an EQ setup. There are different parameters that I can set, as already said before, like frequency, the gain, and the bandwidth, or Q. Since this is a graphic EQ, we can freely move around some of the filter selectors. For each filter selector, we can set them different parameters. Like here, we can set a different frequency, or here, different bandwidth, or here, a different volume. You can see how they can influence when I play a sound with different frequencies. This is how we can control certain frequencies of a sound. For example, if we have a very high C that is very annoying to our ears, for example like this, we can filter it out by using an EQ. Here we have different parameters that we can set, like frequency, gain, and bandwidth, and there are also some other settings like stereo, left, right, and whatever. But what's important for us is the whole curve that we create. When we have a graphic equalizer, we can set different filter selections, and in total you can set 8. And for each filter selections, there are some presets that we can set. For example, that we want a cutoff at the end, a very abrupt one. So if we now play high C, we can filter it out, and now we don't hear it anymore. So if we play one frequency that is lower than that, we can still hear it, but much less than normal ones. If we go lower, we hear it normally. And if we go down the EQ spectrum, we can't hear it anymore. This is how we control different spectrums of the EQ. For example, if we want to hear the lows, so the bass, so it gets boostier, we can boost the one here or the two here to get some more volume of the basses. And if we want to get some louder treble, then we just get the 4 and put it up here, or 3. That is how we control the whole EQ spectrum. Next up, the compressor. Besides the EQ, the compressor is also one of the most commonly used audio effects in the music industry. Compressors are mostly used in live sessions, bands, and other music-related live events. Since an instrument can be played at different volumes, sometimes an instrument could be played too loud to either play over the other instruments or break our ears. For this reason, a compressor is used to limit a played sound or compress it enough so it doesn't play it as loud. Same as the EQ, there are also different types of compressors. A downward compression limits the volume after a certain amplitude, after which it softens and lowers very loud sounds to a normal level. An upward compression works in the opposite way. Instead of limiting the volume, it increases very silent sounds to an audible level. With this in mind, there is also the multiband compression, which allows to have 3 different compressors over 3 different frequency ranges, usually the lows, mids, and highs. Now that we have the basic knowledge of the compressor, let's get back to Ableton. So, here we are back in Ableton. I have another project open with a serum preset and a compressor open. Now, as you can see, there are several things that you can set in a preset, for example, a ratio, an attack, and a release. The ratio defines how much the compressor should compress a sound based on a volume. So, if the ratio is 4:1, if the sound is playing 4 decibels above the threshold, then it's going to compress it down from 4 decibels louder to 1 decibel louder. And if the compression ratio is infinite to 1, then that means if a sound is being played above the threshold, it's going to be compressed down until the threshold volume has been achieved. The attack and release basically define the responsiveness of the compressor. The attack defines how fast the compressor should react after a sound has reached above the threshold. The release basically defines how long it should still compress the audio after it went below the threshold. Then there are some other stuff like the knee that defines how abrupt it should react to the volume change. Then there's the look ahead that allows the compressor to do more accurate compressions, but in return it delays the audio. Then there are some other settings like peak, RMS, and expand but the most important ones are the peak and RMS. With the peak setting, the computer works with how it perceives the volume changes. But because we have different perceptions of volume than the computers, there's also the RMS setting that is more accurate to our perception of volume. Then of course, there's the threshold that defines after which volume the compressor should start compressing the sound. So, enough talking about the compressor, and let's see it in action. Up there, I have set up a clip that will alternate in volume from low to high. Down here in the compression, we can see the thresh, GR and out. The thresh is the input that we get, the out is the output that we get, and the GR is the amount of compression the sound will get based on the volume. So, let's see how it works. As you just saw, the volume increased, but the volume that was outputted was still the same. We have seen this in a grid, but it also can exist in a graph as well. So if we go over here and we play it again, you can see how it exactly outputs, inputs, and compresses the whole sound. Next up, reverb. You've maybe not heard of reverb before, but you most definitely have experienced it. In scientific terms, we call reverberation the persistence of sound after it has been played. We experience this a lot, for example in big empty rooms or halls. That's what the audio effect achieves as well. The reverb also has different types, but much more than the compressor or the EQ. Since the audio effect imitates reverberation, we usually talk more about presets instead of types. And since there are so many, only a few get used the most. Specifically, there's the hall reverb, which creates big and longer reverbs, the room reverb, which creates smaller and shorter ones, and the plate reverb, which imitates the sound of passing as a vibrating plate, which creates thin reverbs but emphasizes the high frequencies. Let's get back to Ableton real quick. So here's Ableton again. I have a plugin set up and some reverb set up, and as you can see I have different reverbs set up because those are different presets. Since the reverb audio effect has many different parameters that we can set and define, for example pre-delay, size, decay and so on, we won't look at this, but instead how just different reverb presets work, for example a hall, a room and some kind of plate. For each reverb preset, I will play it one time and you will see how it affects the audio based on the parameters that are set. Now that we have seen how the reverb works, the most important parameter on each reverb is the dry and wet. As already mentioned before in the beginning, the dry and wet defines how much of which audio should be outputted. The dry is the unprocessed audio and the wet is the processed audio. So if we set the dry and wet to 50%, it's going to play 50% of the unprocessed audio and 50% of the processed audio, and would sound like this. Then if we set the dry and wet to 0%, it's only going to play the unprocessed audio. At 100% only the wet audio, so only the processed one. And 50, both of them. At last, there's the delay. The delay basically works like an echo. But instead of waves reflecting off of surfaces, the input sound gets recorded and replayed after a certain amount of time. These kinds of effects are recursive, so to speak. Same as the reverb, the delay tries to imitate different delay occurrences. So instead of types, a lot of presets are used. Let's get back to Ableton for one last time. So, same as the reverb, the delay has many different parameters that we can set. For example, left, right, mode, and so on. But the most important ones are the feedback and dry-wet. The feedback defines how much of the outputted signal should be reused in the delay. This creates the echo-like effect. So now, if we play a certain sound and use the delay, it will sound like this. And now if we change the feedback to 95%, it's going to be inputting more of the output than before and would sound like this. Basically, it would be an infinite delay. And here as well, we can set the dry and wet signal, so if you want only the wet, it would output only the wet signal. Now, you should know all of the basics about audio effects and some general ones like the EQ and compressor. I hope you liked the video, and if you did, a like and subscribe would always be appreciated. Thanks for watching.